Alright guys, so we've been talking about perimeter, and the perimeter is the outside measurement of a polygon or an object. And we've also been starting to talk about area, which is the entire surface, or think about it as the inside of the object. Like the inside of the fence up here, that's the area. Or if you think about it as the entire surface of your desk, the whole part, not just the outside of it, but the whole inside part as well, that's the area. So the area is two-dimensional. It has a length and a width, and it's measured in square units. Remember, it's like we have all those little tiny squares that we fill the surface with, and those are the and they form an array, and that is the area that we're talking about. They're called square units, and they are measured in square inches, square feet, square yards, square meters, square miles, and hopefully you have a better understanding of when you would use the different units for using inches on your desk versus using feet and yards in your backyard for the different size objects that you are measuring. And so again, the area of a polygon is the number of square units that covers the whole inside of that polygon, that shape. And so far we've been working with regular shaped objects, like this rectangle here. It's a regular shape, it's not irregular. And you could easily find the area of this by counting the squares that are inside this one, since it's drawn on graph paper and actually has the square units drawn for you, or if you remember, by multiplying the length times the width. And that's actually a lot quicker now that we've gotten into a lot of multiplication, and I can just do 9 times 5, and that's again 45. But what happens if you want to try to find the area of an irregular shaped object, an object that's not in the shape of a perfect square or a perfect rectangle? What if it looks something like this here? Well, again, because this is on the graph paper, this one's not too difficult, because you could simply count the squares that are on the inside. I can see all these squares inside. I can start here and just simply count them. But where this becomes a little bit more challenging is when I don't have all the squares just to simply count, when I have just the measurements on the outside. So I first want to show you what this looks like using graph paper so you can see exactly what I'm doing. But I have the measurements on this, and I can find them by counting the edges here. So it's 1, 2, this 3, 4, 5, 6. So this is 6, and we'll call it feet. So this side of this object is 6 feet. Could be a room, or could be anything. This is 6 feet. This is 1, 2, 3, 4 feet on this side. Then on this side down here, it's going to be 4. This side's going to be 6 feet. And this bottom side's going to be 3 feet. This side is 2. And this last side measurement here is going to be 3. Now, finding perimeter on this would be easy. I would just add up all the sides. But finding area, if I don't have all the squares on the inside, is going to be a little bit more challenging, because I can't just simply take my length up here, 6, and multiply it by my width down here, because I'm missing this section here. It's not a regular square, or it's not a perfectly shaped rectangle. So I would not be able to do that. So instead, I have to sort of take these irregular shapes, and I have to form regular shapes, regular rectangles. And I can do that on this one by cutting it into two separate rectangles. I can make this one rectangle coming up here like this. Here's one rectangle I could create out of this shape. And then I could also do this other rectangle over here. I can find the area of this rectangle, the green one that I just did, and I can also find the area of this red one. And when I add them together, I will be able to find the total area of my irregular shaped room. And I can actually sort of separate these two, and you can kind of see it. So I have this one over here, and then I have this red one. Okay? And so essentially I made this problem that looked kind of hard, I turned it into two easy problems. I know how to solve and find the area of a perfectly shaped rectangle, so I turned this problem into an irregular shape, into two regular shapes, and I just have to add them together. Well, the red one, this side was 6 feet, and I took this measurement here, which was 3. So if I do my formula for finding the area, which is length times width, I can do 6 times 3, and that's going to give me 18. So my red section here is going to be 18 square feet. Okay? And then I just find my green area, and I looked here, and I don't want to use this top measurement for that. I want to use this length down here, which is 3, and I want to use this length on this side, which is 4, and I can just multiply 3 times 4, and this green area is going to be 12 square feet. And then my last step in this is just adding these two sections back together. It's sort of like I'm taking them, okay, and adding them back to where they were, kind of like putting that one back in there, and then taking this one, and sliding it back in here. I found this area, I found this area, and I add them together, and that's going to give me, you know, that total area of this whole thing. 18 plus 12, well, 8 and 2 is 10. Regroup my 1, I have 3 10s over there, so it's 30. So this whole irregular shape is going to be 30 square feet. So again, I took an irregular shape and I made two regular shapes out of it, then adding them back together to find out the total area. Okay? Let's take a look at some of these other ones. So again, now I don't have the graph paper, so I can't just simply count the squares. So I really have to be able to section off those those areas to find the two separate areas. Like for instance, this top one, I could go ahead and draw a line here, and now I created this one rectangle here and the second rectangle here. I need to find the area of the two rectangles I created, add them back together to find the total area of the shape of the bigger shape. So up in number 1, I can take my 7 and I can multiply it by 2, because that's the length of this side versus the width of this side, and that's going to give me 14. So that one would be 14 square centimeters. Okay? Now in the second rectangle I created, I can take my length here, and I want to take this width here. I don't want to use this 7 because remember that 7's measuring from way up here all the way down here. I want to use the 5 because I'm looking at this pretend rectangle here that I created. 3 times 5 is going to give me 15 square centimeters. I add them together, 14 plus 15, and that's going to give me 29. So this object over here, this one is 29 square centimeters. Okay? Now let's take a look at this other one. When you're doing this, you can kind of section them off any way you want. However, sometimes it's not quite that simple because you don't have all the measurements. On this shape here, I don't have all my measurements. I don't know what the measurement of this is. I don't know this little part here. And I don't know this part here. So that makes finding the square units of this surface kind of difficult. But if I separate it correctly, then I should have no problem doing so. And I'm going to do that by breaking up. I broke this other one up into 2 rectangles. Well, I'm actually going to break this shape up into 3 rectangles. I'm going to do so by drawing a line here and drawing a line here. Okay? So now I have 1, 2, 3 rectangles that I need to find the area of. And when I find all 3, then I can just add them together and get my final answer. Well, this first one's easy. I can take my length, the 6 feet, the one I have, versus this width here, 6 times 4, and that's going to give me 24 square feet. I know the writing's terrible on this. I apologize. Okay, so that one's 24 square feet. This middle, number 2, I can't quite figure out yet. I don't have all the measurements I need there yet, and I'm going to show you how to find that out in a second. Okay, so that brings me down here to 4 feet, and this one, number 3, is just like the top one. That is 24 as well. Okay, that one's going to be 24 square feet. Well, this middle section is the part I have trouble with. Okay. I can figure this out because I know the measurement from this top part here to this corner is 10. Well, because this side over here is 4, this imaginary line I drew right here, I can tell from here to this imaginary line is also going to be 4 because of what we have learned about rectangles. Remember, the opposite sides are always the same side. Like this 6 feet and this one here is 6 feet. Okay, this is 4 feet and this is 4 feet. So I can tell from here to here is 4 feet. So if the whole thing is 10 feet, then if I subtract 4 feet from it, then I know this middle section here has got to be 6 feet. Okay? And if I go to this section here, it runs about halfway in between my rectangle. Well, what's half of 6? Because my measurement up here is 6. Well, that's going to be 3. So if I take 3 and I multiply it by 6, that's going to give me 18 square feet for that middle section. And we'll practice how to find these measurements in class. Okay, so now I have all the square units for section 1, 2, and 3, and I just have to add them up. So let's do the ones that are easy first. I'm going to do 24 and 24. And that's going to give me 4 and 4 is 8. It's going to give me 48. So this section and this section was 48. Now I just have to add in my smaller section. 48 plus 18 is going to be 8 and 8 is 16. Carry my 1. That's going to be 66 square feet.